object. Now two objects are placed on the principal axis means where the images will be formed, and then what is the distance between that images and all we have discussed yesterday. And before that we have discussed about the rules and all, image rules and then incident ray rules. This and all are the different problems we have discussed in that, and we have almost done all the problems, all the types of problems. And I said already the mirrors is not much important. It is you learn, but what I am saying means whoever the people having the confidence and then they don't want to miss any one problem also, you just learn everything, plane mirror and then spherical mirror. The people who cannot do that much physics and then who are not having that much confidence in that, I will tell you particular topics in this, that is one is prism, another is the telescopes. That is enough for you. Whoever are not able to do all the problems in physics and then who want to do the easier problems only, then prism compulsory question, prism and then telescopes and then microscopes. And the remaining people you have to do everything, lens and then spherical mirrors and then plane mirrors, everything. And now today we are going to discuss about the refraction. In refraction topic, it is not much important for the NEET, by the way, and also in this only different topics will be there. Whenever an observer is observing from the rarer medium to the denser medium, at that time apparent shift will be there. What the shift means? For example, whenever you are just standing out of the swimming pool and then you are just looking at the floor of the swimming pool, bottom end of the swimming pool, at that time what you will feel? You will feel that it is not having that much height, depth is less. So actual depth is different, and then you are feeling that it is not having that much depth. That is known as apparent shift. And also whenever, for example, a shark is looking at the bird which is flying in the sky. So shark is there inside of the water. Inside of the water means which medium that is? Denser medium. Denser medium nothing but density will be more, and then rarer medium means density will be lesser. Okay na? Density of the denser medium is more, density of the rarer medium is less. At that time, whenever the shark want to catch that bird which is flying in the sky, at that time what happens? Nothing but shark will look at the bird. Bird height is less actually, but what shark will feel? Nothing but it is having more height than what I thought. So that will aim to last height only. So that is a apparent shift whenever it is looking from the denser medium to rarer medium. These are the two types of problems which are important, pretty important. One is whenever you are looking from the rarer medium to denser medium. For example, a bird is catching a smaller fish which is already swimming in the water. At that time what happens? Nothing but the real depth of the fish is different, and then it appears like it is coming above only. That is known as the apparent shift. And also whenever the shark is looking at the bird, otherwise whenever the person who is swimming and then who is looking at the flight which is flying in the sky, at that time the actual height is less and then apparent height will be more. That is the apparent shift. The difference between them is known as the apparent shift, otherwise apparent height. And also whenever you might be done the practicals, botany practicals mainly, whenever you have taken the glass slab and then down of that you will take the cells. So whenever you are taking the cells, actual depth is different. You are looking that above the actual depth. That is also we known as a normal shift. Whenever we come to the glass slab, that is known as a normal shift. If we are coming to the different mediums, water and then air, otherwise glass and then air, whatever it might be, at that time we call it as apparent shift. These are the different cases will be there. After that we will have the total internal reflection, and after that critical angle will be there, and after that we will get the curved surfaces, and then lenses will get. So this whatever we are having now, apparent shift and all, actually derived by the sine angles, angle of incidence and then angle of refraction. But I will not touch that topics. I will just solve by the refraction formula only. One refraction formula will be there, only by that. Actually refraction formula will come in the curved surfaces. But now only I will take that and then I will solve by using only that. I will not touch any sine angles, I will not touch any cos angles and all. Angle of incidence and then angle of refraction and all I will not touch. I will not take any triangles and then I will not take any trigonometric problems. Okay, directly we will solve by the refraction formula only. The refraction formula mainly is, the refraction formula is known as mu2 by v minus mu1 by u is equals to mu2 minus mu1 by r. The same formula we are going to get for the lenses also. As per now, you just remember the formula, that's it. By using this formula, we can solve everything very easily. So only I am taking this one. So here, what is the mu means? Refractive index. What is the refractive index means? The ratio of speed of the light in the vacuum by speed of the light in medium. Nothing but mu is equals to, I can say, C divided by V. C is nothing but what? Speed of the light in vacuum, and then V nothing but speed of the light in the particular medium whichever we have taken. So that is a refractive index. We will discuss that later. First and foremost is refraction we will discuss. What do you mean by refraction? Refraction means what? What is the refraction? It is just like a deviation phenomena only. Whenever the light is crossing one boundary which is separating the mediums, at that time what happens means light will bend. So that bending phenomena is known as a refraction. And before we have discussed about the angle of deviation. In angle of deviation we have taken only one medium we have taken, other one is directly boundary only. At that time what was happening? Light was hitting and then it was coming back. That is a reflection. In that reflection we have discussed about the deviation. The deviation formula is what? Delta is equals to 180 minus 2i, otherwise 180 minus 2r we can take. That is about the deviation we have discussed in that. Now we are taking two transparent mediums. Transparent mediums means in two of the mediums light can travel. In deviation topic we have taken only one transparent medium, another is directly boundary. For example, wall. This is the air medium, then the wall. Whenever the light is hitting the wall, it is reflecting back. So that is about the reflection and then deviation we have discussed. Now this is a refraction. Refraction means, for example, if I take, this is the air medium, this is the water medium. Air medium and then water medium. This is the boundary which is separating the two mediums here. Inside water I have taken. Can we see the light in water? Can we see the light or not? Yes, we can see the light in water. So that light is entering into the water also. Then what happens means, whenever the light is incident on the boundary with angle of incidence I, then what happens means it will bend. Whenever it is crossing one medium to another medium, whenever it is touching the boundary, at that time what happens means it will bend towards the medium, towards the normal, towards the normal. This is the angle of refraction. Whenever you see, this is the original path. Now what happened? It is bending like this. That bending phenomena is known as a refraction. Clear? So whenever the light is entering from one medium to another medium, and whenever it hits the boundary, then what happens means it will bend from its original path. That bending phenomena is known as a refraction. Okay, that refraction angle is, we will discuss with the R only, and then incident angle is I. It is not reflecting. Reflecting nothing but what happens? Bounce back into the same medium. Okay, that also will take by the R only. This is also by the R only. Now reflection will never come. Wherever we are indicating the R, that is a refraction angle only. Refracting angle only. So now whenever the light is entering into the from one medium to another medium and then incident on a boundary, then what happens? It will bend from its original path. It will bend either in an inward direction or outward direction just based on the mediums. Okay, we will discuss that mediums also. Then that bending phenomena is known as a refraction here. In this, one important law will be there. What is that law? Snell's law. Yes, do you remember that? Snell's law. What Snell's law will states? Yes, the product of refractive index and then sine of the angle is always constant. So only you might be remember that mu1 sin I is equals to mu2 sin R. Correct? That is the Snell's law. Snell's law nothing but the product of refractive index and then the sine of the angle. Sine of the angle with respect to the water, normal. With respect to the normal, we have to take the angle. That is always constant. The product will be always constant. Now whenever you come here, this is the refractive index mu1, air medium. Obviously air value is how much? Refractive index value 1. Okay. Next refractive index of the water is mu2, let us consider. This is not about the air and water, any other mediums. I have taken mu1 medium and then mu2 medium. In mu1 medium, what is the angle we are getting here? I. And then in the mu2 medium, how much? R. So that here mu1 sin I, nothing but first medium and then first angle, is equals to what I can write, mu 2 sin r. Always constant, nothing but what I can say, initial is equals to final. In medium 1 is equals to medium 2 I can write. So mu 1 sin I is equals to mu 2 sin r. Here this mu 2 by mu 1 is equals to what I can write, mu 2 by mu 1 is equals to sin I by sin r. Sin I by sin r. Then here if I take mu 1 as the air, then what I can write, air refractive index is how much, 1. Then mu is equals to simply what I can write, sin I by sin r. And this mu 2 by mu 1, the ratio is known as a relative refractive index. We will discuss that. Okay, the ratio is known as relative refractive index. This is a Snell's law. Snell's law states that the product of the refractive index and then sine of the angle with respect to what always? With respect to the normal drawn to the boundary is always constant. This is the normal drawn. This is a normal drawn. With respect to the normal, this is the angle of incidence, this is the angle of refraction. So that product will be always constant, means initial value is equals to final value. From that only we got this value. And now we will see about the refractive index. What is the refractive index means? Refractive index means simply the ratio of velocity of the light in the vacuum. C is nothing but what? Velocity of light in vacuum divided by velocity of light in medium. V is the velocity of light in medium. Mu is equals to C by V. This is known as a refractive index or absolute refractive index. Anything is correct only. Mu is equals to C by V. What is the unit of mu? No units. Why? Because this is also speed only, this is also speed. For example, if I say mu of the air, nothing but the value of the value of the light in the vacuum is always C only. However, the velocity of the light in air is how much? Velocity of the light in air is also same like vacuum only almost. So that what I can say, this is also C only. Then what is the answer here? 1. So only I have taken here mu 1 as 1. Clear? That is about the absolute refractive index. Next one is relative refractive index. Relative refractive index, nothing but we are taking one medium with respect to the other medium. That is a relative refractive index means. So you might be seeing this kind of notation that mu 21. Mu 21 nothing but here the refractive index of medium 2 with respect to medium 1. That is what you have to mainly remember, don't confuse in this. Mu 21. The same thing again, same notation you will get in the magnetism also. Okay, whenever you come to the mutual inductance topic in the EMI chapter, then also you will get same notation. There also everything is same. There we will get the capital M21. Nothing but the what you have to take, nothing but outer coil divided by inner coil you have to take like that. So the same thing here also, the relative refractive index nothing but mu 21. The refractive index of medium 2 with respect to the medium 1. How to write this formula? Nothing but mu 21 is equals to what I can write, mu 2 by mu 1. In the words only I am saying that medium 2 with respect to the medium 1. Medium 2 out of the medium 1. Okay. Now mu nothing but what is the formula for us? C by V, right? So that C is however constant only, C by V2 divided by mu 1 nothing but what I can write, C by V1. Then what I can write, V1 by V2 in terms of wavelength. What you can write in terms of wavelength? V is equals to what is the formula? You finish the waves chapter, entire waves chapter, and then you don't know. V is equals to what is that? F lambda. If you are getting any confusion, I will tell you one short trick for that. Velocity is equals to what is the formula for us? Distance by time. So the distance is what here? Wavelength, and then time is t only. 1 by t is nothing but what? Frequency again. Clear? That is how you have to remember that. So V is equals to F into lambda. Then V is directly proportional to lambda. Why I am taking frequency as constant here? Why I am taking frequency as constant? Whenever the wave is crossing the bound any medium, frequency does not changes. Wavelength changes, speed changes, intensity also changes, but what happens? The frequency does not changes. Always it will be constant only. In the wave optics also it will be useful, you have to remember that. Frequency does not change whenever the medium is changing. So frequency is constant, so only I can write it as V is directly proportional to lambda. Whenever the V is directly proportional to lambda, then what I can say this one as lambda 1 by lambda 2. Clear? Where lambda 1 nothing but what? Wavelength of the light in medium 1 divided by the wavelength of the light in medium 2. Clear? This is about the relative refractive index. Listen again everything. So here refraction nothing but whenever the light is traveling from one medium to another medium, whenever it is hitting the boundary, at that time it will change its original path. It will deviate from its original path. That bending phenomena is known as a refraction phenomena here. Angle of incidence is I in medium 1, angle of refraction is R in the medium 2. Don't take R nothing but reflection. Now it is refraction. Reflection means what happens? It will bounce back into the same medium. If it is going into other medium means completely you have to take it as a refraction only. Going to the same medium means it will be reflection obviously. So that bending phenomena is known as a refraction phenomena. In this one law is very important, that is a Snell's law. This is also law of refraction we can say. The Snell's law states that always the product of refractive index and the sign of the angle with respect to the normal is always constant. So is always constant nothing but initial value is equals to final value. Initially in medium 1, finally in medium 2. So the product of refractive index and then sign of the angle, so that mu 1 sin I is equals to mu 2 sin R. That is mu 1 sin I is equals to mu 2 sin R. Then we can take the ratio and then from that we got mu is equals to sin I by sin R. If I take mu 1 as which medium? Air medium. Okay. Now this refractive index or absolute refractive index means what is? That is mu is equals to the ratio of velocity of light in the vacuum divided by the velocity of light in medium. So from that mu of the air what I can write means that is simply C by C only, that is how much? 1. For the glass it will be different, for the water it will be different, for the glycerin it will be different, for the mercury it will be different. Whatever the value might be they are asking, they will give in the bracket only. You no need to remember anything. Okay. So but air you remember that always mu of the air is how much? 1. After that relative refractive index, nothing but we are talking about one medium with respect to the other medium. So here refractive index of the second medium with respect to the first medium means you have to denote like this, mu 2 1. So mu 2 1 is equals to what I can write? Mu 2 by mu 1. Always the second medium with respect to the first medium. Mu 2 formula is what? C by V2 and then mu 1 is C by V1. C gets cancelled, V1 by V2. From that I want to get the wavelength relation nothing but that is ಅರೆ ಏನು ನಿದ್ದೆ ಯಾಕೆ ತಗೋ ನಿನ್ನ ಜಾಗದಲ್ಲಿ ನೀವೇ ತಗೋ ತಿನ್ನು ಎಲ್ಲ ಒಂದೇ ಸರಿ. ಸೊ V1 by V2 is equals to lambda 1 by lambda 2. This is about the refractive index of the second medium with respect to the first medium. Now I want to get first medium with respect to the second medium. Mu 1 2 is how much? Mu 1 by mu 2. Can I write it as 1 by mu 2 by mu 1? Correct. So mu 1 by mu 2 nothing but what I can write? Simply this one I can write as 1 by mu 2 by mu 1. Can I write like that? Yes. Then 1 by mu 2 by mu 1 nothing but what? Mu 2 with respect to 1. So mu 1 2 is equals to the 1 by mu 2 with respect to the 1. Always they will be inversely proportional whenever you are interchanging the mediums. Okay. Whenever I am talking about 2 to 1, that will be equals to 1 by 1 to 2. Clear? So that only mu 1 to 2 is equals to 1 by mu 2 to 1. Clear? Yes, write that refraction. First sari ಕೇಳಿದ್ದೀವಿ, ಸೆಕೆಂಡ್ ಸರಿ ಯಾಕೆ ಕೇಳಬೇಕು ಆಲ್ರೆಡಿ ಅರ್ಥ ಆಯ್ತಲ್ಲ ನಿದ್ದೆ ಮಾಡ್ತಾ ಇದ್ವಾ? Write that refraction. When the light moves from one medium to other medium, when the light moves from one medium to other medium, it will deviate from its original path deviates from its original path, this phenomena is refraction. This phenomena is refraction. Next, Snell's law. The product of refractive index and sine of the angle with respect to the normal, is always constant, is always constant. Is always constant, that is mu sin theta is equals to constant. Mu sin theta is equals to constant. Copy that Snell's law. ತಗೋ, ಯಾವಾಗ ನಿದ್ದೆ ಬರುತ್ತೇನೋ ಆವಾಗ ತಿನ್ನು. ಕೊಡು ಎಲ್ಲರಿಗೆ. ಥೂ, ಸೆಲ್ಫಿಶ್ ಫೆಲೋ. ನೀವು 6 ಚಾಕ್ಲೇಟ್ ಕೇಳಿದ್ವಿ, ನಾನು ಎಷ್ಟು ಚಾಕ್ಲೇಟ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ ನೋಡು. ಏನು ಅಕ್ಷತಾ, ಏನು ಸ್ಮೆಲ್ ಬರ್ತಾಯಿದೆ ನಿಮಗೆ? ಮುಖ ಮುಚ್ಕೊಂಡು ಕಣ್ಣು ಮುಚ್ಕೊಂಡು ಏನು ಕ್ಲಾಸ್ ಕೇಳ್ತಾರಮ್ಮ ನೀವು? ಮುಕ್ಕು ಅಂದರೆ ಏನಂದರೆ, ನೋಸ್ ಅಂದರೆ ಏನಂತಾರೆ? ಮೂಗು ಅಂತಾರ. ನೆಕ್ಸ್ಟ್, ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್. ಎವ್ರಿಥಿಂಗ್ ಯು ಕಾಪಿಡಾ? ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್, the ratio of speed of the light in vacuum to the speed of the light in medium, in bracket you write absolute refractive index. Write the formula, mu is equals to C by V. Then mu of the air is equals to 1. Next, relative refractive index. Copy that relative refractive index. Finished, huh? Everything you write as it is. In that relative refractive index only you write one line. When the light travels from one medium to other, its frequency remains constant. Speed, wavelength, intensity changes. Speed, wavelength, intensity changes. ಕೇಳಿಸ್ಕೊತಾ ಇದ್ದೀನಿ, ಸೌಂಡ್ ಬರ್ತಾ ಇದೆ ನಮಗೆ ಕೂಡ. See that here light is traveling from rarer medium to denser medium. In which medium light can travel easily? Rarer medium, obviously. Why? Because density is very less. For example, if you take the air and then water, at that time what happens? Air will be the rarer medium, water will be the denser medium. If you take the water and then honey, so which is the rarer medium? Water is the rarer medium and then honey will be the denser medium. Like that we will take the different mediums and all. Now whenever the light is traveling from the rarer medium to denser medium, at that time what happens? How it will bend? Towards the normal or away from the normal? Towards the normal. Why? Because that cannot move that much freely. Okay, that much freely it cannot move, so only what happens? Light will bend towards the normal. This is the angle of refraction. So whenever the light is traveling from the rarer medium to denser medium, that will bend towards the normal. This is a normal drawn to the boundary, and then it was having this much of angle before. Now angle of refraction is less. So what is the relation between the angle of incidence and then angle of refraction? I greater or otherwise R greater? I greater than R. I greater than R. Now tell me the V1 V2 relation. V1 nothing but the velocity in medium 1, velocity V2 is velocity in medium 2. V1 is greater than V2. Obviously we can run very easily in the air, we cannot run that much easily in the water. So that in the same way light also cannot do like that. So V1 will be greater than V2. Now tell me the refractive indexes, mu1 and then mu2 relation. Which is greater? Mu2 is greater than mu1. Why? Because mu is inversely proportional to the velocity. Correct? In medium 2 what happens? Velocity is less. Velocity is less, nothing but refractive index will be more. So only I can say mu2 greater than mu1. Otherwise mu1 less than mu2. And then this is about the velocities, this is about the refractive, this one angle of incidence and then angle of refraction. Clear? And then after that, whenever you take the denser medium to rarer medium, then what happens? How it will move? For example, I have taken water in the glass and then I am observing the light under the glass. So just in the air, I have taken one glass of water and then in that I just put a torch, otherwise laser light like that, and then I am just observing below that how the shadow is going to be. Then this is how the angle of incidence. Angle of incidence. Then what happens? How the light will bend? It is free to move, otherwise it is difficult. Free to move in the rarer medium. So what happens? It will immediately go away from the normal. This is the angle of refraction. This is the denser medium and then rarer medium. Rarer medium. Now here the velocity is V1, let us consider this is the velocity is V2. Then now tell me the relations. Here what I can say, I is lesser or more? Less than R. I less than R. And also I can say that V1 less than V2. Why? Because V1 is in the denser medium. And also what I can say, mu1 greater than mu2. Clear? This is the relations between the angle of incidences and then refraction, velocities and then refractive indexes. Clear? Rarer to denser and then denser to rarer. Always you just remember that In the denser medium, the light field will feel difficult to move, so that only what happens, it will bend towards the normal. In the rarer medium, it will move away from the normal. Clear? Copy that. Both the cases you copy. That is the theory also. Light bends away from the normal when finished. Next, refraction formula. Right, as it is first, I will explain that. ಎವ್ರಿಥಿಂಗ್ ಯು ರೈಟ್ ಆ್ಯಸ್ ಇಟ್ ಈಸ್. ತೊಗೊರಿ, ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡಿರಿ, ಪರವಾಗಿಲ್ಲ. ಯು ಕ್ಯಾನ್ ಮಾಡಿ, ಏನಾಗಲ್ಲ. ಪಾಪ ಹಸು ಆಗುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ. ಒಂದೊಂದು ತಗೋರೆ ಒಬ್ರೊಬ್ರು. Like you are just fighting like Varada Baditul, Varada flood people will be there, no, like that only. Huh? Girls ge beda, only boys ge. Nodri Uday girls ge beda anta idru. ನಿಮಗೆ ಪುಣ್ಯ ಬರುತ್ತಲ್ಲ ಎಲ್ಲರಿಗೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡಿದ್ವು ಅಂದರೆ, ಅದಕ್ಕನೇ. ಚಾಕ್ಲೇಟ್ ಪೇಪರ್ಸ್ ಕೊಟ್ಟಿದ್ರು ಅವ್ರು, ನೋಡ್ರಿ. ನಮಗೇನು ಬೇಡ, ನೀವೇ ತಿನ್ನಿರಿ. ತೊಗೋರಿ ಎಲ್ಲರೂ ತೊಗೋರಿ. ಫಸ್ಟ್ ಬಾಯ್ಸ್ ತೊಗೋರಿ. ತಗೊಂಡಿದ್ರಾ ಎಲ್ಲರೂ? ಸೈಫ್ಗೆ ಕೊಟ್ಟಿದ್ರಾ? ತೊಗೋರಮ್ಮ ಗರ್ಲ್ಸ್. ಪ್ರಜ್ವಲ್ ಒಂದೇ ತಗೋ. ಫಿನಿಶ್ಡಾ? ಹಾಂ, ಇವತ್ತು ಯಾರ್ದು? ಫಸ್ಟದ ಸೆಕೆಂಡ್ದ? ಹಾಂ, ಏನೇನು ಅರ್ಥ ಆಗಿಲ್ಲ. ಹಾಂ, ಚಾಕ್ಲೇಟ್ ಡ್ರಾಪರ್ ಏನು ಮಾಡಬೇಕು? ಅವರೆಲ್ಲ ಕ್ಲೀನ್ ಮಾಡಬೇಕೆಲ್ಲ ರೂಮಲ್ಲ. ಫಿನಿಶ್ಡಾ? ತಿಂದ್ರೆ ಎಲ್ಲರೂ? ಹಾಂ, ಯಾರು? ನಾವು ಹಿಯರ್ ದಿಸ್ ಈಸ್ ದ ರಿಫ್ರಾಕ್ಷನ್ ಫಾರ್ಮುಲಾ. ಹಾಂ, ಗೊತ್ತಾಯಿತು. ಟೈಮ್ ಆಗಿಲ್ಲ ಇನ್ನು. ಅಲಾರಮ್ ರಿಂಗ್ ಆಗ್ತಾ ಇದೆ. ನೀವು ಎಷ್ಟು ಜೋರ ಹಾಕಿದೆ ಅಂದರೆ ಕೂಡ ನಾನು ಬಿಡಲ್ಲ. 1:30ಗೆ ಕ್ಲಾಸ್ ಬಿಡ್ತೀನಿ. ವಯ್ಯಮ್ಮ ವಯ್ಯ, ಅದೇ ₹1 ಚಾಕ್ಲೇಟ್ ಅಮ್ಮ ಐಶ್ವರ್ಯ. ಆಫ್ಟರ್ ಆಲ್ ₹1 ಚಾಕ್ಲೇಟ್. ಮತ್ತು ನೀವು ಡೇಸ್ ಕಾಲರು ಆ ಪಕ್ಕ ಅವ್ರುಗಳು ಕೊಡ್ರಮ್ಮ, ಅನ್ಯಾಯ ಮಾಡಬೇಡ್ರಿ, ಪಾಪ ಬರುತ್ತೆ ನಿಮ್ಮೆಲ್ಲರಿಗೆ. ಎಸ್ ಸರ್, ನಮ್ಮದು ನಿಮ್ಮದು ಬಾಕಿ ಏನಿಲ್ಲಪ್ಪ, ಮುಗೀತು ಎಲ್ಲ. ಸೊ μ2/v minus μ1/u is equals to μ2 minus μ1/r. So in the curved surfaces, actually diffraction through the curved surfaces, at that time μ1 indicates the object medium and then μ2 indicates the image medium. But now you just assume that μ1 is the first medium where the object is placed, μ2 is the other side of the boundary. For example, if I say here I kept the object, in the rarer medium I kept the object, this is μ1. Wherever I kept the object, that is a medium 1, otherwise μ1. Then where we are observing from the other side, observer medium we can say, otherwise the other side of the boundary. Other side of the boundary nothing but this one, water. That will be having how much refractive index here? μ2. In the curved surfaces, that will be, one will be the image medium, another is the object medium. So there we will discuss about that clearly. Now here you just have to assume that μ1 indicates the refractive index of the medium 1 where the object is placed. Object medium is μ1. Next μ2 is the simply other medium, that's it. That might be having the image or that might be having the observer. Anything it can be, but the other medium you have to take it as a μ2. Then after that, r is nothing but radius of curvature of the boundary. So for example, if I take the curved surface, at that time this will be the radius of curvature. This will be the radius of curvature of the boundary. Now which surfaces we will take here? Plane only, right? There is no bending, nothing at all. So that plane nothing but radius will be how much? For the plane, what is the radius? Infinite only. It is not a circle. It is not closing. So infinite radius will be there for the plane mirror, otherwise plane surface. So only r is infinity here. Then after that, u is nothing but the object distance from the boundary, v is nothing but image distance from the boundary. Here image nothing but the object will appears like. I said already, for example, if I take this is the what is the depth of the swimming pool I have taken. Here I kept one mark here, one dot I kept. Whenever I am looking from the outside, at that time what happens, nothing but I will not look this what is the dot here, actually it will appears here. So this is the image, this is the object. It is appearing is a image, finally where we are seeing that is the image position. So whenever I consider this as a boundary, this is the image distance and then this is the object distance. This is the surface of the boundary I have taken. Clear? So that here u is nothing but the object distance, otherwise the actual distance or actual depth of the object. Next one is v is nothing but image distance, that is the apparent depth. Okay, that is about all the nomenclatures of this formula, that is mu2 by v minus mu1 by u is equals to mu2 minus mu1 by r. Now as per now we are using all which boundaries here, plane or otherwise curved? Plane surfaces only. Plane surface nothing but what I said, r is infinity. R is infinity, nothing but what I can say, mu2 by v minus mu1 by u is equals to something by infinity is how much? 0. Then what I can write, simply mu1 by u is equals to mu2 by v. This is for the plane surfaces. Write that for the plane boundaries. For the plane boundaries, mu1 by u is equals to mu2 by v. This is everything about the basic introduction of refraction. Now we will see the refraction through the plane surfaces. Next we will see the refraction through the curved surfaces. In the plane surfaces, already I said that whenever the object is placed in the denser medium, what is the apparent shift will be. Whenever the object is kept in the rarer medium, at that time what will be the apparent shift will be. In denser medium what happens, nothing but its depth will decreases. It is at the deeper inside, nothing but it will appears in the top. That is about the denser medium. Whenever the object is placed in the rarer medium, it will be increases as per the actual height. More than the actual height it will show. So for example, whenever the shark is seeing at the bird, means at that time bird appears more height than actual. Whenever the bird is seeing a small fish inside of the water, means it will appears like it is coming above only than the actual depth. So that is about the phenomena between the rarer to the denser and then denser to the rarer. And after that we will see the glass slab. And after that we'll have one more concept, that is the lateral shift. That will be compulsorily, we have to get the formula by the sine angles only, angle of incidence and then angle of refraction. If they have given about the thickness and the refractive index, we have to use apparent shift formula. That formula is d into 1 minus 1 by mu. That formula will be there, I will derive that. Whenever they are giving about the angle of incidence and then angle of refraction and thickness, at that time you have to use one more formula known as x is equals to that is t into sine I minus r by cos r. These are the two different formulas will be there. One is a normal shift, another is a lateral shift. Whenever you are using the angle of incidence and then angle of refraction, that is a lateral shift. Whenever you are using the depth and then whatever the refractive index, that is a normal shift. Okay. So you have just basic idea about that. We will discuss everything in deep. Now refraction by the plane surfaces. Once we enter into the curved surfaces, we will get the lenses there. Now through the plane surfaces we will discuss. Now in that first case is object placed in the denser medium and then viewed from the rarer medium. are observed. First case is this one. Object is placed in the denser medium and viewed from the rarer medium. Write one thing in that. Whenever the object is placed in the denser medium and viewed from the rarer medium, then it appears like its depth is less than the original depth. It appears like its depth is less than the original depth. Wherever object is there, from there only light will be incident. Already we know that in the curved mirrors only, already we have discussed in the spherical mirrors. Wherever the object will be placed, from there only you have to take the incident ray. Now here, look at this, object is placed in the denser medium and then observer is there in the rarer medium. Now object is placed in nothing but, for example, you just think that here one torchlight is kept. Inside of the water, one torchlight is kept, and then don't question me that it will get spoiled whenever it is there in the water. Okay, I will put in the glass box and then I will put in the water. Okay, now, ಮತ್ತೆ medium change ಆಗುತ್ತಲ್ಲ, I will take in the glass medium only then. Waterproof torchlight I will take. So here, object I placed here, light I placed here. Then what happens? Obviously on the boundary the light will incident. It is travelling from which medium to which medium? Denser to the rarer. Then what happens? Bends away from the normal or towards the normal? Away from the normal, so that the light will bend like this. So light will bend like this, away from the normal. Whenever it is bending away from the normal, what happens? I said it will appears like it is having the less depth. So this is the actual depth of the object, actual depth, d actual. Otherwise I can say actual depth is what? I can indicate with u or v. Actual u, object distance is u. Then where I am seeing this object means whenever I just extend this light ray, here I am seeing that object. So this is the, which depth this is? Apparent depth. This is the actual depth and then this is the apparent depth. This is d apparent, or what I can write, that is v. Now what is the shift means? Apparent shift means what I can write? The shift of this one from the real place to the appearance place. So what is that? I can write it as x. X is equal simply what I can write? U minus v, otherwise DAC minus DAP. Anything is correct only. So whenever the object is placed in the denser medium, it appears like it is having the less depth. How it is possible? Nothing but whenever I kept the object here and here observer is there. Now what I am doing? Nothing but from here I just kept one light here on the boundary. Then what happens? It is travelling from the denser medium to rarer medium, means it will bend away from the normal. Now what I am doing? I am just extending that in the opposite direction. Then I am just feeling that object is placed here. This is O, means what I can write? This is O dash. This is the apparent depth, DAP. This is the actual depth, DAC. Now the shift nothing but the original depth minus the apparent depth, so that is U minus V. Finally we can get. We have to find out this one only finally. Before that you have to use the refraction formula. This is which boundary, by the way? Plane boundary only, right? Plane boundary nothing but R is infinity. At that time what is the condition we will get? Mu 1 by U is equals to mu 2 by V. What is the mu 1 here? Refractive index of which medium? Object medium, right? Refractive index of the, this one you have to remember, otherwise you will get confused here. Mu 1 nothing but refractive index of the object medium. Object medium is this one. So let me take, this is mu and then this is air, nothing but mu 2 is how much? Mu 2 is air, that is 1, mu 1 is mu only I will take. Clear? Now mu 1 is how much I said? Mu, that divided by the object distance is how much here I can write? DAC, otherwise u we can write, anything is correct only. That is equals to mu 2, nothing but what I said? Other medium I said. Other medium is which medium? Obviously air medium, so that only that will be 1, and V value is how much? DAP. Then here apparent depth DAP is equals to what I can write? DAC by mu. Correct? Then shift is equals to, the apparent shift is equals to, x is equals to what I can write? Original depth minus apparent depth, that is D actual minus D apparent. D actual is D actual only, minus D apparent is how much? D actual by mu. Then what I can take common here? D actual I can take common, 1 minus 1 by mu. One of the important formula. X is equals to D actual into 1 minus 1 by mu. Listen again, one more time you listen. So here object is placed in the denser medium, it appears like it is having the less depth whenever you are looking from the rarer medium. This rarer medium I have taken as a air, and then this denser medium I have taken as a water. Now whenever the object is observed from the rarer medium, at that time what happens? I have taken the object here, I will take that in the denser medium, the light is travelling and then hitting the boundary here. Whenever it is travelling from the denser to the rarer, then what happens? It will bend away from the normal, so only bended away from the normal. Whenever I extend that in the opposite direction, then whatever the point, final point I am getting, there only I am observing the object, otherwise the object is appearing there only. That is the apparent depth, and then this is the real depth or actual depth. Actual depth is nothing but object distance only, that is u. Apparent depth is image distance v. Now whenever you see from the refraction formula, so here this will be very difficult by using the I and R formulas and all, so only I am not touching that, directly we will solve by the refraction formula only. From the refraction formula, mu 1 by u is equals to mu 2 by v. What is the reason why we got this only? R is infinity, very good. Then mu 1 is nothing but the denser medium from where the object is placed, so mu 1 is mu, that divided by object distance is what here? Actual depth D actual, that is equals to mu 2 is which medium here? Air medium. If it is not air medium, you have to take that medium refractive index. Okay. Now mu 2 divided by D apparent, image distance. From that D apparent is equals to D actual by mu, then apparent shift is equals to, otherwise I can say apparent depth, anything is correct only. Apparent depth, otherwise apparent shift. Apparent depth is this one, no? Yes. No, apparent shift only, that is shift or apparent shift. So shift is equals to x is equals to what I can say? Actual depth minus apparent depth. So from that D actual into 1 minus 1 by mu. This is a formula. Here mu is the refractive index of which medium? Mu is the refractive index of which medium? Denser medium where the object is placed. Correct? Yes. This is the example for, write the example also directly from the, for the formulas. You have written the theory, no, already? It appears with less height and all. Copy directly. Finished? Next, object placed in the rarer medium and observed from the denser medium. Write that. When the object observed from the denser medium, object observed from the denser medium placed in rarer medium, it appears like it has more height than original. It has more height than original. Look at the diagram. So here I place the object in the rarer medium in the air, and now I am observing from the denser medium. So whenever I observe from the denser medium, actually what happens, always from the object what rays will come? Incidence rays will come. So incidenting on the boundary, and then whenever they are coming from the rarer medium to denser medium, then what happens? It will bend towards the normal. So that light has bent towards the normal. Now I am extending in the other direction. Then what happening? Nothing but now I can observe the object here, that is a O dash. This is the original height, this is the apparent height. The difference between them is known as what? Shift only. So that shift is the apparent height minus original height, gives you the shift. Now you have to find out the shift, by the way, and also here the observer is there in the second medium, let me take that is a mu, and then object is there in the first medium, that is the mu1 is how much here? 1. Yes. Copy that and then solve that. Solve the answer. Tell me the x value, how much will come. Derive the answer in the same way and get the x value. One minus? Yeah. Look at that properly. D apparent ಬರ್ತಾ ಇದೆ, ಆ್ಯಕ್ಚುಲಿ ಇದು ಹೆಚ್ಚು ಆ್ಯಕ್ಚುಯಲ್ ತಗೋ, ಹೆಚ್ಚು ಆ್ಯಕ್ಚುಯಲ್ ತೊಗೊಂಡು ಮಾಡು. D H actual into mu minus 1 1 minus mu na? Mu minus 1. Sarasam, something is going on in Pramod and then Shreyas bench. See that he is putting the bag there and then he is becoming closer and closer. H actual into mu minus 1, correct? H apparent is equals to H actual into mu minus 1. Look at this. Again the same formula, mu 1 by u is equals to mu 2 by v. So mu 1 is nothing but which medium? Object medium, right? Object medium value is how much here? 1. So that 1 divided by u is nothing but actual height. Actual height is what I can write, HEAC is equals to mu 2 nothing but other medium, obviously. What is the value of the other medium? Mu divided by v is nothing but apparent height, you have to take, that is H apparent. Now here I want to find out the shift. Shift nothing but x is equals to what I can write? X is equals to what I can write? H apparent minus H actual. So that H apparent minus H actual. So apparent value is how much here? H apparent is equals to mu by H actual. Same or different? Mu into, yeah, mu into H actual. So that here apparent is equals to mu into H actual minus H actual. Then we can take HAC common and then mu minus 1. This is a shift whenever the object is placed in the rarer medium and then observed from the denser medium. Can you see this one? Last people? Can you see here? Otherwise shall I write in above? Our height is Ramma, ಅವ್ರಿಗೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್. ಅದೇ ಬೇಕು ಅನ್ನೋ ಸೌಂಡ್ ಮಾಡ್ತಾಯಿದ್ರು, ಗೊತ್ತು ನಮಗೆ. ಚಾಕ್ಲೇಟ್ ಇಲ್ಲ ಏನಿಲ್ಲ, ಎಲ್ಲರೂ ಕೊಟ್ಟಿದ್ರೆ ಆಲ್ರೆಡಿ. So object viewed from the glass slab. Object viewed from the glass slab. There is no need of any derivation. I will tell you the direct formula. Same formula only. There is no change in that. Now here I have taken the glass slab like this. Glass slab I have taken of thickness T. Otherwise the thickness D. Anything is same only. Now here I kept the object. Here I kept the object. This is the object O. Now what happens always from the object? Incident ray will come and then falls on the boundary. Incident ray is coming and then falling on the boundary. This is a normal drawn. Then what happens? It is travelling from which medium to which medium? Rarer medium to denser medium. Whenever it is travelling into the denser medium, then what happens? Bends towards the normal. Instead of going in this way only, it will just bends like this towards the normal. Then after that again the light is travelling and then hitting the other boundary. This boundary is separating which mediums here? Denser medium to rarer medium. Now whenever the light is travelling from the denser medium to rarer medium, then what happens? It will go away from the normal in this way. That is what will happen here in the refraction. You understand properly? This one will be there in the next application also. So here object is placed in the rarer medium and then the light will travel from the rarer to the denser and then denser to the rarer. Whenever it is placed in the air, at that time the light ray is going like this and then hitting the boundary. Hitting the boundary with respect to the normal, and then whenever it is travelling from the rarer medium to denser medium, then what happens? Bends towards the normal. So instead of going in this way, it is bending like this. Bending, and then after that it is crossing the glass slab also. This is another boundary which is separating the denser medium and rarer medium. Let me take this medium is having the refractive index is mu. Obviously glass slab I have taken, I can take it as a mu g, mu glass. Then again light is coming out of the glass. Out of the glass means this is a boundary coming from the denser medium to rarer medium. Then what happens? It will bend away from the normal. It is bending like this. Now whenever I extended this ray, whenever I extend this ray, here it is coming. This is a O dash. Original distance was this one. Now apparent distance is this one. Clear? The observer is there here, by the way. Observer is there here, by the way. So the observer is looking from here. Then actual distance of this one is object is here, but it is appearing here. So this is the shift. This shift is normal to the boundary. So only we know it as a normal shift. And also this is the actual distance, and then this one is the apparent distance. Actual distance and then apparent distance. Now what is that shift will be means? X is equals to the normal shift. Normal shift. X is equals to what I can write, nothing but what is the thickness of the glass here? T is the thickness of the glass. So the T into 1 minus 1 by mu. The same formula only. Here instead of actual distance and all, we will get the thickness there. That's it. There is no need to do the derivation and all again. That will be based on the incident ray and then reflector ray. Refractor ray, by the way. So this is the formula. X is equals to T into 1 minus 1 by mu. Why it is a normal shift? The shift is with what angle? With the boundary. Normally only, right? 90 degrees only. This is the boundary I have taken. With respect to the boundary, this direction is normal direction only. So only it is a normal shift. So don't take these distances and all. You just write as it is directly. It appears closer than the original distance. Close. Window na. ಯಾವುದು ಫಸ್ಟ್ ಇದೆ? ಸಾತ್ವಿಕ ಓಕೆನಾ? ಈಗ When object is viewed from the glass slab, we'll go wait for 5 minutes. Close that door. When object is viewed from the glass slab, then it appears closer than the original distance. Then it appears closer than the original distance. Closer than the original distance. And the shift will be towards the glass slab. Shift will be towards the glass slab. Normal to the boundary. Normal to the boundary. So this shift is known as a normal shift. This shift is known as a normal shift. Look at this. Here I have taken this as a glass slab. Look at this. This is a glass slab I have taken. Down I kept, for example, I want to see this wire. Wire is there in the below. Otherwise I want to see the floor. Now what I am doing, nothing but whenever I just look without the glass, at that time what happens, I will take the original height of that floor, whatever depth it is there. Now what I am doing, nothing but I am taking the glass slab of thickness T. Very smaller thickness will be there. Already you know in the labs, already in the biology labs, very smaller thickness will be there. Whenever I look from that glass slab. So whenever I look from that glass slab, actual floor is not there for me. It is not appearing there. It is just come towards me. So this is shift. So the shift is there in which direction to the boundary? Normally. So only that is a normal shift. And also whenever the light is traveling from the down object, so light is traveling like this and then hitting the boundary, coming from rarer medium to the denser medium, then what happens, nothing but it will bend away from the normal. It is bending away from the normal and then away towards the normal. So whenever it is coming towards the normal, at that time again it is coming out of this boundary again, second boundary. So from that second boundary it is coming from which medium to which medium? Denser medium to rarer medium. Then what happens, nothing but it will bend away from the normal. So due to that away from the normal, I am just extending in the opposite direction. There what happens, nothing but my ray will meet the boundary here. That is a O dash, apparent depth, otherwise apparent shift I can say. So this is completely shifting normal to the boundary. Whatever the shifts we have discussed yet, everything is a normal shift only. By the way, this is also coming normal to the boundary only. This is also coming normal to the boundary only. And then this is also coming normal to the boundary only. Normal shift is equals to x is equals to thickness of the glass into 1 minus 1 by mu. What is the mu here? Refractive index of glass medium. Okay. Right, that where T is the thickness of glass. T is the thickness of glass and mu is a refractive index of the glass medium. Mu is a refractive index of the glass medium. Will you go for lunch? Otherwise one more concept is there. Shall I clear that? Will you go for lunch? There is no need to ask also.